For thousands of years, if you looked up at the night sky, the explanation for what you saw was straightforward. You were standing still, and the universe was moving around you. Early astronomical models placed the Earth firmly anchored at the center of creation, with the stars and planets locked into spheres rotating overhead. In 1543, Polish astronomer Nikolaus Copernicus published a model that broke that structure apart. He placed the Sun at the center of our local system, pushing the Earth out into an orbit alongside the other planets. This heliocentric model physically displaced humanity from the center of existence. A few decades later, Galileo Galilei applied rigorous mathematical observation to this new arrangement. By formulating the principle of circular inertia and tracking the trajectories of moving bodies, he developed a standardized scientific method to measure the heavens. He proved that celestial objects obeyed consistent rules rather than divine whims. Humanity had to recognize its true peripheral location in space before anyone could accurately measure the mechanics keeping the planets in motion. Removing our planet from the center of the cosmos allowed observers to finally focus on the physical laws governing the universe. Building on these early observations, Isaac Newton derived his laws of universal gravitation. By proving that a falling apple and a rotating planet are guided by the exact same forces, Newton showed that the entire cosmos operates on rigid, predictable mathematics. That framework expanded in the 19th century with James Clerk Maxwell, who discovered that electricity and magnetism are interwoven into continuous fields. These invisible forces permeate all of space, proving that physical reality operates well outside the limits of human perception. Then, Albert Einstein took those rules and stretched them. With his theories of relativity, he dismantled Newton's idea of a rigid, clockwork universe. Einstein demonstrated that mass, energy, space, and time are not independent forces. Instead, they are deeply interwoven. A massive object like a star literally warps the physical fabric of space and time around it. The development of physics and optics, the very tools used to track gravity and light through space, provided the blueprint for studying the microworld. The same mathematical rigor used to map a planet's orbit was now ready to be applied to the microscopic building blocks of life. This era of scientific curiosity shifted its focus from the immense scale of the cosmos to the inner workings of a cell. Charles Darwin established the overarching mechanism for biological change. He proposed that species evolve over time through natural selection, where traits that aid survival are passed down to future generations, linking all living things through a common ancestry. Almost simultaneously, an Augustinian friar named Gregor Mendel found the math behind Darwin's theory. By meticulously crossbreeding pea plants, Mendel discovered that biological inheritance isn't a random blending of traits. It is governed by dominant and recessive genetic markers. Together, these discoveries demonstrated that life itself is built on a structured framework. Every physical trait and variation is dictated by a decipherable microscopic code. Identifying that microscopic structure allowed researchers to combat the threats living within it. French chemist Louis Pasteur formulated the germ theory of disease, proving that fermentation and many illnesses are caused by specific, invisible microorganisms. British surgeon Joseph Lister took Pasteur's findings and applied them directly to the operating table. By introducing rigorous antiseptic routines and sterilizing instruments, Lister drastically reduced post-surgical infections. Decades later, American physician Jonas Salk achieved an incredible level of control over this microworld. He developed the first safe and effective vaccine for polio, preemptively teaching the human immune system to destroy a virus before it could paralyze its host. By locating and neutralizing these microscopic pathogens, we took control of our own biology. This extension of human life created a booming population, which required a massive increase in physical resources and infrastructure to support it. To support modern civilization, humanity had to take the physical laws of the universe and use them to harness immense amounts of environmental energy. Scottish inventor James Watt provided the initial spark. By radically improving the efficiency of the steam engine, he allowed factories and transport systems to rely on machine power instead of human or animal muscle. British scientist Michael Faraday figured out how to extract energy in a completely new format. He discovered principles that allowed electricity to be generated and captured as a usable, practical resource. Serbian-American engineer Nikola Tesla solved the problem of moving that energy. He developed and patented the alternating current system, which allowed high-voltage electricity to be transmitted efficiently across vast geographical distances. Generating raw power in one location and instantly delivering it to another allowed cities to expand and industries to scale up. It formed the physical infrastructure required to connect human society on a global level. Henry Ford utilized this industrial scale to refine mass production. By streamlining the assembly line, he reduced the cost of complex machines, turning the automobile into an accessible tool for the middle class and restructuring the layout of modern cities. In the 1940s, this mastery of industrial engineering collided with theoretical physics. J. Robert Oppenheimer directed the theoretical development of the atomic bomb, taking Einstein's equations and turning them into a physical mechanism. Splitting the atom was the ultimate realization of applied science. It demonstrated that humans could isolate the basic forces of the cosmos and engineer them to release terrifying amounts of energy. The modern world is the physical legacy of these findings, from the vaccines that extended our lives to the electrical grids that power our cities. These 15 individuals replaced mystery with a documented map of physical laws.
Thank you for watching and sticking around till the end of this video. If you learned something from it or enjoyed it, please give it a like and consider subscribing for more science-related content like this. Depending on when you're watching this, you could indulge yourself in a couple more videos that I'm sure you'll find interesting. They should be on the screen right now. See you in the next one.